Hello guys, this is Bpong unit and today my discussion topic is substation layout and accessories and busbar arrangement. So let's begin. I have divided the whole session into two parts. Part A will be substation layout. I will discuss about the various types of equipment which are used in substation, and second one will be different types of bus bars. So in part A, I will discuss single line diagram, substation switchboard accessories, lighting arresters or LA, which is also called as surge arrestor, then capacitive voltage transformer or CVT, then earthing switch, then wave trap, then isolator, current transformer, circuit breaker, power transformer, reactor and capacitors, other switchboard equipments, then PLCC and SCADA. Before starting with the substation equipment, let's start describe what is substation and what is difference between substation and switchboard. Many people get confused that switchboard is a substation or what is switchboard, what is substation. So let's clarify this first. Yard means field. So where the all equipments are mounted or placed, that field is called switchboard. And the whole area including control room building, others building if it is available, the whole place is called substation. So switchyard is a part of substation, but substation is not part of switchyard. There are various types of substation. So based on working, there are four types of substation. First one is generating substation or step-up substation. Generating means, as the name suggests, that where the electricity has been generated, and that associated substation is called generating substation. Generally, electricity is generated at 13.8 kV or 15 or 16 kV, what is modern substation. So from that it is stepped up to 132 kV or 200 to 220 kV or 400 kV. So these substations are called generating substation. Then comes grid substation. Grid substation is the place where it is connected to the grid, that 132 kV to 20 kV, it may be any type of voltage what is available in India. So it is called grid substation. Then switching substation, and then secondary substation. Secondary substation is also divided into three categories, that is transmission voltage, primary distribution and distribution substation. I will discuss on everything later, where I will discuss about the substations only, not on the equipments. Today our discussion is only on the equipment. So based on the structure, the substations are divided in four categories, that is outdoor conventional or air insulated substation, which is generally called as AIS. Then comes indoor substation, then compressed air insulated substation, and then gas insulated substation or GIS. Nowadays mostly popular substation is GIS, and AIS is also used in India. Many people who now let's start about the each equipment designing or so first I will discuss about the lighting arrestor. Lighting arrestor, what is a lighting arrestor? A lighting arrestor is a device used on electrical power system to protect the insulation of the whole substation from damaging the base effect of lightning. These are the base. Okay. So if lightning occurs, what lighting arrestor does, lighting arrestor captures this and send it to the ground or Mother Earth. So our equipment are protected. So the location of the lighting arrestor is the first equipment which are placed on the every incoming line, and it is situated on the both side of a power transformer, because power transformer is the mostly costly equipment in the substation. So to protect it in both sides, lighting arrestors are used. Metal oxide varistor or MOVs have been used for power system protection since mid 1970, and it is the most used equipment which are used inside lighting arrestor. The typical lighting arrestor is also known as surge arrestor, and It has a high voltage terminal and ground terminal. Current from the surge is diverted around the protected insulation, in most cases to the earth, what I have discussed. This is a picture of surge arrestor or lighting arrestors. This is CVT or capacitive voltage transformer or capacitance coupled voltage transformer, CCVT. So it is similar to the PT or potential transformer or VT or voltage transformer, but there is a major difference between CVT and voltage transformer or VT. What is that? In VT it is used in lower voltage level and CVTs are used in higher voltage level, generally above and from 132 kV. So what happened in CVT is that there are two capacitors are used, and between two capacitors there is a voltage drop, as we know, and from that voltage drop it is calculated the primary voltage level. So instead of using the huge primary voltage level, we are using the voltage drop voltage. So the whole equipment size is getting reduced. So this is the advantage of CVT over VT. And what is purpose is CVT? That it step down extra high voltage signal, provide a low voltage and measurement or to operate protective relay. That it just creates the image of the primary voltage to a lower level secondary voltage. Arc switch is used to discharge the voltage or current on the circuit to the earth for safety. Arc switch is mounted on the frame of isolator. It is line trap or well trap communication line in the power transmission line. What is the role is that it blocks the high frequency carrier waves, that is 24 kHz to 500 kHz, and let the power waves, which is generally 50 Hz to 60 Hz, to pass through. In India, power frequency is 50 Hz. It basically is an inductor of rating millihenry, approx 1 millihenry for 220 kV and 1250 amps. It has three main components. First one is main coil, then turning device, and third one is lighting arrestor. The next very essential equipment is isolator or disconnector. It is used to make sure that electrical circuit can completely de-energize for service or maintenance. It is to remember that isolator is an offload device while circuit breaker is an onload device. That means that while the line is in charge or current is passing through the line, we can operate circuit breaker. It is an onload. But while circuit breaker has been operated, now no current is passing through the line, then we can operate isolator. There is various classification of isolator, but types generally include that central rotating horizontal swing, then center break isolator, then vertical swing isolator, and fourth one is a pantograph type isolator. The next one of the major equipment in a substation is the current transformer or CT. Current transformer is used to step down current for measurement, protection and control. There are two types of current transformer or CT. First one is a protective CT and second one is a measuring CT. Next is circuit breakers. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by overload or short circuit. Its basic function is to detect fault condition and by interrupting continuity to immediate discontinue electrical flow. All circuit breaker has common feature in their operation. All the details vary substantially depending on the voltage class, current rating and type of circuit breaker, but all circuit breakers have the common features. What are the features is that once fault is detected, contacts within circuit breaker must be opened to interrupt the circuit. Small circuit breaker may be manually operated. Larger unit have solenoid to trip the mechanism and electric motor to restore energy to the spring. There is a spring in circuit breaker which generally opens the contacts, moving contacts and the fixed contact, and then closing those contacts. Fixed contacts are fixed and moving contacts only movable. This is the picture of circuit breaker. There is no rotating part because everything is done inside the circuit breaker. As in isolator, we can see the movable part, it is moving while it is in operation, but in circuit breaker you cannot see anything from outside. And also to remember that what I have said, that isolators are offload device and circuit breakers are onload device. While contacts are being separated in circuit breaker, there is an arc, and to extinguish or mitigating the arc, different techniques are used. Those are lengthening or deflection of the arc, immense cooling in jet chamber, it is through air, division into partial arcs, 0-point quenching, connecting capacitor in parallel with contacts in DC circuit. High voltage circuit breakers are broadly classified the medium used to extinguish the arc. Those are bulk oil, minimum oil, air blast, vacuum or SF6. SF6 is now highly popular and mostly used in all substations which are rated from 66 kV. The next equipment in the substations are busbar. Busbar receive power from incoming circuit and deliver power to the outgoing circuits. Then the major equipment in the substation is a power transformer. It is the costliest equipment in the substation. Power transformer used to step up or step down AC voltage and to transfer electric power from one voltage level to another voltage level. Suppose from 33 kV to 132 kV, that is step up, and step down is suppose 220 kV to 132 or 33 kV. Shunt reactors are used for long EHV transmission line to control voltage during low load period. EHV means extra high voltages. Shunt reactor is also used to compensate shunt capacitor of transmission line during low load periods. Usually shunt reactors are unswitched. Series reactors are used to limit short circuit current and limit current surges associated with the fluctuating loads. Series reactors are located at the strategic location such as fault levels are reduced. So where fault level can be reduced, there series reactors are used. Shunt capacitors are used for compensating reactive power to LPF. They are used for improving power factor. It is also used for voltage control during heavy lagging power factor loads. They are located at the receiving station and distribution substations. Shunt reactors are switched during heavy loads and switched off during low loads. Series capacitors are used for some long HVAC lines to improve power transferability. They are located at the sending end or receiving end of the lines. They are provided with bypass circuit breaker and protective spark gaps. Neutral grounding equipments are resistors and reactors. They are used to limit the short circuit current during ground fault. They are connected between neutral point and ground. Other switchhead equipments on which I have not discussed are marshalling kiosks, station earthing systems, power cable and control cables, insulator, metering, relay and control panel, and supply system. I will discuss on those things on a later video. PLCC or power line carrier communication is mainly used for telecommunication, teleprotection and telemonitoring between electrical substations through power lines at high voltages such as 130 kV, 220 kV, 400 kV or higher. The voice signal is converted or compressed into 300 Hz to 4000 Hz range. The other names of the PLCC are Power Line Digital Subscriber Line PDSL, Mains Communication, Power Line Telecom or PLT, Power Line Networking or PLN, Broadband over Power Lines BPL. Next comes from automation is SCADA. The full form of SCADA is Supervisory Control and Data Acquisition. It is not full control panel but rather focused on the supervisory level. It is a purely software package that is positioned on top of hardware to which it is transferred. It doesn't generally direct communicate with the hardware. It communicate with the hardwares with PLC or programmable logic controllers. The major role of SCADAs are data collection or data acquisition, data transmission or telemetry, scanning, indication, monitoring and logging, control and indication, ensure sequentially events, that which one will be happen when that 1 2 3 4, this is the sequenciation. So on this sequence it ensures the event, data presentation, display and reporting, execution of opening commands, on off, raise lower, those things, network supervision, alarm and report any uncommon change of state.